Hello student, my name is Anil. So today we are going to start our chapter Haloalkanes and Haloarenes. So Haloalkanes and Haloarenes. So chapter itself tell about the introduction of the chapter. The name itself tell the introduction of the chapter that Haloalkanes means halo word come from the halogen, and we know that alkane means carbon containing single bond, and this halogen again halo word come from the halogen, and arenes means aromatic compound. Okay. Now we know that halogens are fluorine, chlorine, bromine and iodine. These collectively known as halogens. तो जो एल्कीन्स के साथ अगर हेलोजेंस हैं तो उनको क्या बोलेंगे? हेलो एल्कीन्स. अगर एरोमेटिक कंपाउंड्स में हेलोजन है तो उनको कहेंगे हेलोएरिन्स. तो देखते हैं क्लासिफिकेशन. सबसे पहले halogen compounds के. Now, if we have an alkene CH4, अगर इसका इस मीथेन का अगर कोई एक हाइड्रोजन को हम रिप्लेस कर दें किसी भी हेलोजन से, suppose we have replaced hydrogen by fluorine, then we get fluoromethane. Or we can replace another hydrogen from this fluoromethane, then we get difluoromethane. So like this we can replace hydrogen from an alkane and with the halogen to form haloalkane compounds. Now here you can see we have only one halogen compound, one halogen in the compound, so it's mono haloalkane. And here we have two halogen compounds, so it's dihaloalkane. Like this, so on, tri and tetra. So like this we have different haloalkanes on the basis of number of halogen compounds attached with them. Okay, then these halogen compounds also classify on the basis of the degree, like we have primary, secondary and tertiary compounds. See, we have CH3, CH2, Br or bromoethane. So this bromine is attached to this carbon and this carbon is primary. So how to count that is primary or secondary? The carbon which have the halogen have two hydrogen, so we have formula 3 minus H. H means number of hydrogen, so 3 minus H. Here hydrogens are 2, so 3 minus 2 we get 1. That means it's a primary haloalkane. Now we have another example, CH3 CH Br CH3. So in this halogen is attached to this carbon, and here we have one hydrogen, so 3 minus 1 we get 2. That means this carbon is secondary carbon. Now another example for the tertiary, we have CH3 CH3 Br and CH3. So here we have no hydrogen, 0 hydrogen, so 3 minus 0 means 3. So this carbon is tertiary carbon. So like this we have classified haloalkane on the basis of the primary, secondary and tertiary carbon. Now come to the aromatic halogen compounds, means haloalkanes. Aromatic halogen compounds, or they are also known as Haloarenes. So Haloarenes arenes means aromatic. So if halogen is attached to the arenes, so they are also divided into two parts. First one is if halogen is directly attached to the benzene ring, like we have chlorine, chlorobenzene. Chlorine is directly attached to the benzene. Or we have CH3 toluene, and then bromine is attached to the toluene. So 4-bromotoluene. So bromine is directly attached to the toluene, and here chlorine is directly attached to the benzene. So these are known as nuclear halogens. They are known as nuclear halogen because halogen is directly attached to the benzene ring. So another classification is in which halogen is not attached directly to the benzene ring. Your example, phenyl methane. Okay, 1-chloro-phenyl methane. So in this compound you can see chlorine is attached to the carbon, which is attached to the phenyl group. So this is non-nuclear halogens, in which you can say halogen is not attached directly to the benzene ring. So another example you can take, like we have CH, Cl, Cl. Okay, here two halogen compound attached to the carbon, which is further attached to the phenyl group. So like this we can classify them into nuclear and non-nuclear aromatic compounds. So further classification of the halogen compounds, haloalkanes and haloarenes, is based on the hybridization. We already discussed, if we have a primary haloalkane, the carbon to which halogen is attached is sp3 hybridized. This is sp3 hybridized. Whether it is primary, secondary or tertiary, the carbon is sp3 hybridized in 3 of these cases. Now there are more examples in which halogen is attached to the sp3 hybridized, like we have Allylic Halides. So what is allylic halides? Allylic halides are those compounds in which halogen is attached to a carbon, which is further attached to the carbon-carbon containing double bond. Means this carbon is attached to the carbon-carbon containing double bond. Such kinds of compounds are known as allylic halides. Okay. So this carbon to which halogen is attached is also sp3 hybridized. Another example we can take, like we have chlorine, and here we have double bond, cyclohexane. Okay, so 1, 2 and 3 chloro cyclohexane. Okay, So in this compound you can see this carbon is sp3 hybridized. Okay, now if you see, we have vinylic halides. So what is vinylic halides? The carbon-carbon containing double bond and halogen is directly attached to them is known as vinylic halides. In these vinylic halides, the carbon which is attached to the halogen is sp2 hybridized. Or we can say another example of sp2 hybridized carbon, we have chlorobenzene, in which chlorine is attached to this carbon which is sp2 hybridized. Means if a halogen is directly attached to the benzene ring, that carbon is sp2 hybridized. So this is general classification of the haloalkanes and haloarenes. In next video we will see how halogen compounds are prepared.